are some graphs of polar equations that are exclusive, so to speak, to the polar system. Okay, you can, well, I don't want to say you can't graph them in the rectangular system, but they're kind of exclusive to the polar system. Now, the first one, these are obviously not exclusive to the polar system. Circles, okay, we've just been dealing with converting their equations. We have looked at them not being centered on an axis, but here we're just going to focus on if they are centered on an axis. So the simple circle equations, r is equal to a cosine of theta. Well, cosine goes with x, so it makes sense that that graph is centered on the x-axis. R is equal to a sine of theta. That graph is centered on the y-axis. Now, here's the great thing. On the final exam, you have Desmos. You can graph this, okay? It's not a matter of being able to produce the graph, so we're not really going to go through making a table and plotting the points and drawing the graph by hand because we have technology for that. But what you do need to know here in a second when we get to the exclusive ones, you need to know their names, and then you just need to know some of their characteristics. So notice what this one says. They are circles with a diameter of length A. A is the coefficient in front of the cosine or in front of the sine. So I already mentioned that the cosine means that it's centered on the x-axis, meaning the diameter lies on the x-axis. If it's sine, then it's centered on the y-axis. So if you're asked a question about the radius, you've got to divide that number by 2 because that number is the diameter there. Okay, so circles, pretty simple. Okay, here are a new type of graph. These are called limacons. It's a French word. I'm not a French expert at all. Pretty sure I'm pronouncing that correctly. If I'm not, someone please correct me. But these are limacons. So in a limacon, you have a constant plus the coefficient cosine of theta, a constant plus the coefficient sine of theta. So it's almost like a circle, but you're adding or subtracting something in front of or after the trig ratio there. So the ratio A over B, so when you take the constant by itself and put it over the coefficient, that determines the shape of the limacon. There are 4 different types of limacons that we can have. A limacon can have an inner loop if A divided by B is less than 1. It has an inner loop if A divided by B is less than 1. It's heart-shaped if A over B equals 1. And since they are heart-shaped, they have a special name. We call them cardioids, cardiac. Look for those root words. Those are called cardioids. It's heart-shaped if A over B equals 1. Notice it comes to a point right here and has that kind of bubble coming out. We can have a dimple. Okay, it doesn't come to the sharp point like the cardioid does, but there's kind of a dent in the side right here if A over B is between 1 and 2. And if A over B is greater than 2, there's no dimple, there's no inner loop. We would call this you need to add this word to your notes, a convex limacon. Okay, if you think about a convex lens, it has, I don't know, it's almost flat right there. It's not completely circular. I tried to do my best to draw it. It's not a complete circle, but that's not like a sharp, straight line on that side. It's just kind of flattened a little bit, but it's called a convex limacon. These can also, all of the ones that I drew here are centered on the x-axis, but obviously if it's sine, then they would be oriented on the y-axis. Okay, so that remains the same throughout all of these. Okay, the next one, flip your paper over. The graphs of A times sine of n theta and A times cosine of n theta are called Rose curves. These are Rose curves. So what sets these apart? That number, that coefficient with the theta is what sets these apart from the other ones. All the two other ones that we've looked at so far are just sine of theta or just cosine of theta. These have a number with the theta. If n is even, if that number with the theta is even, your rose has 2 times n petals. I think that's fairly easy to remember. Even 2 is an even number, so you multiply that number by 2 to get the number of petals. Now, again, you got the graph. You can see that. That's not really a complicated thing there, but I just wanted to mention it. If n is odd, it has that number of petals. So if you've got cosine of 3n, that rose is going to have 3 petals. And then when you look at the picture here, you can see that the petal length is that coefficient A. The petal length is the coefficient A. So you might want to add that to the list. A is the petal length. And again, you can observe all of this on the graph. Now, seeing that petal length may be a little bit harder unless you put your graph in polar mode. If you put the polar axis on there, it's pretty easy to see that petal length because you can see the radii. And you can see how these are oriented based on sine versus cosine. And I just tried to give a couple of different examples with 2, 3, 4, and 5 theta there. Okay, and then the last one that we've got, what sets it apart is the r squared. R squared is equal to a squared sine of 2 theta. R squared is equal to a squared cosine of 2 theta. These are called lemniscates. And you can see what they look like. They kind of look like a figure 8, lemniscate, figure 8. Maybe keep that in the back of your mind there. We're trying to, I think obviously a circle's easy. A rose curve is easy because it looks like a flower. So then you've got limesons versus lemniscates. Lemniscates look like a figure 8. The limesons are the other one. Okay. So you can see their graphs there. Notice that the petal length is A, but in the equation, that coefficient is a squared. So you're going to have to take the square root of that number to get your petal length. You're going to have to take the square root of that number to get your petal length. Okay, so let's look at the white sheet for just a second. We're going to look at a few of these and go through just identifying their characteristics really quickly. So the first one there on your white sheet is r is equal to 6 plus cosine of theta. So your instructions on your paper don't give you this much detail. We're going to add these things. We're going to name the curve and the type if applicable. If it's a limason, we need to designate which type of limason, which axis it is centered on, how many petals it has, if it has petals, and the length of those petals. So number 1 there, that doesn't have any petals. That's a limason, right? I know that because of the plus. So let's look at our limason page really quickly. We take the ratio of A over B, the constant over the coefficient. Okay, the constant over the coefficient. So our constant here is 6, this is A, the number in front of cosine is B, there's not a number there, so it's understood to be 1. So A over B is 6 over 1, so it's equal to 6. What does our characteristics say when, whoops, too far. When A over B is greater than or equal to 2, it's a convex limason. So this is a convex limason. Okay, which axis is it centered on? It has cosine, so it's centered on the x-axis. It doesn't have petals because it's not a rose curve and it's not a lemniscate, so we can't talk about the length there. Now, we could, of course, graph this. Okay, we could graph 6 plus cosine theta. And look at that, 6 plus cosine theta. And we need to say that that's equal to r. R equals 6 cosine theta. Okay, so I'm going to zoom out a little bit. Now, here's the downside to graphing this. It's a little hard when it's a convex limacon to tell the difference between this and a circle. So I would put my polar axis on here. And when you do that, if you look at it, you can kind of see, if you compare the left side to the right side, you can see you're not fitting, it looks a little bit different. If you compare it to the closest lines on the graph, there's a little bit of a difference between this side and that side. So you do kind of really need to know when it is a convex limacon or versus being a circle, okay? Because looking at the graph, it's going to look very, very similar. Okay, number 2, I know right off the bat that it's a lemniscate because it has r squared. Lemniscate. Which axis is it centered on? Its sine. Now, if you remember when we looked at the graph, technically the lemniscate's not really centered on the y-axis. It's kind of cockeyed, I guess you would say. We're going to say that that is centered on y equals x, that line y equals x. Now, we're not really going to say that it has 2 petals. We only really talk about the number of petals when it's a rose curve, but we can talk about the length. The length is 5. The length is 5. Because you take that coefficient in front and take the square root of it, so the length of those petals is going to be 5. Okay, number 3, r is equal to 2 sine of theta. That is a circle. It is centered on the y-axis. And it has a radius of 1. The diameter is the coefficient in front of your trig function. So the diameter is 2, so the radius is 1. So if it's a circle, you need to talk about how long its radius is. Okay, let's do one more, number 4. R is equal to 1 plus 2 cosine of theta. This is another limacon. So if we put A over B is 1 over 2. So let's look at what scenario we've got there. If A over B is less than 1, 1/2 is less than 1, we have an inner loop. So we have an inner loop limacon. It is centered, this one's also on the x-axis because it's cosine. And that's all we talk about with our limacons, is which type it is and what axis it's on. So let's look at this one really quick just to confirm. 1 plus 2 cosine theta. You can see very clearly the loop there. So really, I don't think that there's a whole lot that you need to memorize, because most of what you need to figure out, you can tell from the graph. The main things that you do need to know, though, are the difference between a convex limacon and a circle, because it's not super clear on the graph. And pretty much everything else you can figure out using the graph. And you do need to know the difference between a limacon and a lemniscate, because those are similar. I think circle and rose are pretty easy to differentiate there.